Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions and very important concepts. Mainly in this session, we will be talking about the trick which will be helping you to solve all these important questions and the concepts quickly, easily and in less time. And what are the tricks we are going to talk about? These are going to be your atomic and molecular physics tricks. So which will be helping you a lot to solve these important questions and the concepts easily and in very less time. Okay, I was just checking it out like whether everything is all right and clear your side or not, and I think it's all right. Now we can continue the discussion, but before starting the discussion I would like to show you some of the important slides. So this is going to be the first slide I wanted to show you, which is regarding the latest update we are going to have for the Unacademy subscription. And as per this update, you can see that price hike can take place soon. So in that case, if anybody is there who wanted to take the Unacademy subscription or don't want to miss the regular live classes of well structured and well planned courses by the top educators, in that case you can take the subscription before the price hike will be taking place. And other than that, whenever you will proceed further to take the subscription, you can use and apply the referral code, which is Anjali A Live, as mentioned here on the screen. So this was the latest update we had, regarding the Unacademy subscription. And what are the benefits you will be getting if you will be taking the subscription, and all that has been mentioned on this slide. So you can clearly have a look at this and let me know if in case there is anything which is not clear to you or wherever you will be having any doubt. Now let's continue the discussion. So we will be talking about some more important points here. And what are these points? Let's talk about them. Just give me a second. And this is how we will be talking about these important things. Now, so guys, this is going to be our physical science session. Very good afternoon, Simran. Very good afternoon, everyone. Now, the next information is something regarding me on the next slide, and this is about the community post. The next we are going to have here. If I'm going to talk about the next thing, that's going to be regarding the Unacademy Iconic subscription. So all the benefits which you will be getting if you will be taking the Iconic subscription have been shown here. At the same time, what are the benefits you will get if you will be taking the Unacademy Plus subscription? They have been shown here on this slide. What are the benefits you will be getting if you will be taking the Lite subscription? They have been shown here. At the same time, the difference between the Unacademy Plus and the Iconic subscription have been shown here on this slide too. So depending on which one you find more beneficial for yourself and which subscription you want to take, you can proceed further to take that subscription. And the another thing is, whenever you will be proceeding further, use and apply the referral code, which is Anjali A Live, as mentioned here on the screen, and you will be getting the discount in the total subscription amount. So I hope now each and everything is clear to every one of you guys, and that means we can continue the discussion. We can talk about the important points and the concepts here in this session right now. Now, before I'm going to proceed further, I'll be explaining the important tricks and concepts of atomic and molecular physics here. Also, I would like to make few things clear that in whatever situations, in whatever cases you can apply these tricks, I'll be telling you everything clearly. So you just need to focus on this part, that when you can use the trick and when you will not be using the trick. And what exactly is the trick? Like, everything will be getting clear to you. You just need to focus on the discussion for that. And in case if anywhere you will find like something is not getting clear or somewhere there is some doubt, so you can surely mention it. I'll be talking about that point. Now let's continue and let's talk about all these important points. So the first thing I would like to show you is like how to find the ground state spectroscopic term notation. I hope if you have prepared something in atomic and molecular physics, you will be familiar with the LS coupling part. And in that case, you need to know about it, that how to write the spectroscopic term notation. That's the one thing. But how to write the ground state spectroscopic term notation, That's the another thing. While it can be taken in sequence, that firstly we will be finding all the spectroscopic terms, and other than that, the next step will be to check out the ground state spectroscopic term. But what we want to do, we want to save our time in the exam, and for that, what we are gonna do? We will be directly learning a trick here, okay, which will save our time and will be giving us the answer quickly, easily, and in very less time. So let's take some of the examples and let's work on this part. So you will be observing the process which is related to the trick we are going to talk about, and that's how it's going to work. Clear? Now, so I hope everybody knows about the Hund's rule, which is the main thing to identify the ground state spectroscopic term. Okay, but even if somebody is there who doesn't know about it, quickly I'm just going to just state all those statements. Okay, I'll be telling you. So if anybody wants to note it down, they can even do that. As per the Hund's rule, okay, the main thing is you are going to know about the ground state spectroscopic term, okay? And the next thing is 2s plus 1 Lj is the spectroscopic term notation. So how many parts are there? I can even write it like this, Slj, where S is what? It is equal to 2s plus 1. So if I'm gonna consider how many parts are there in the spectroscopic term notation, 3 parts, okay? How 3 parts? Basically S, L and J. So we will be comparing all the 3 parts, and that's how we will get to know about the ground state spectroscopic term. Right now I'm telling you the Hund's rule statement because it's important for you to know. Largest S value, and get to know one more thing, you have to move sequence wise, means you can't jump to the third statement directly without looking at the first one or the second one. Firstly first, then second, then third, sequence wise. Or even if you get something shortlisted, something which is going to provide you some idea about the terms which can be the ground state term, okay, so you will carry it in the further statements. It's not like, okay, it was from the first statement, so I'm gonna leave it now. No, you have to take it for the further steps too, okay? Now, largest S value, lowest energy. If there are 3 terms and in one of the terms S value is the smallest one, which is the 2s plus 1 simply, so it will have the lowest energy. Largest L value, the second position, lowest energy. Then largest or lowest, there are 2 cases for J comparison. How there are 2 cases? Because there can be, for example, in p orbital, maximum number of electrons you can have are 6. So I am taking p2. 2 is what? Less than half filled. Okay, this is what? This is the less than half filled. Clear? Less than half filled. Why? Because you know that in case of p orbital, the maximum number of electrons you can have are what? Less than half filled. Clear? In this case, the maximum number of electrons you can have are 6. So half of 6 is what? It's 3. So 3, it is less than 3 value you had here, which is 2. So which is less than half filled. So when it is less than half filled case, then lowest J value will be having the lowest energy. And it is for what? Less than half filled case. But if it will be more than half filled case, more than, okay, more than half filled case. So in that case, what will happen? In that case, the largest J value will have the lowest energy. So more than, largest J, less than, lowest J, lowest energy. These are the statements as per the Hund's rule. You have to follow them step by step, 1, 2, and the third one, the 2 statements which are there. Now, once you got to know about it, next thing is, what exactly is the trick to find the ground state spectroscopic term? Let's come to that part. So basically, if I'm going to talk about, like, let's say there is an element, there is a term, there is something notation given to us, and we need to write the spectroscopic term notation for that. It can be, for example, P3. Okay, I'm taking the exactly half filled case because you may have a question in your mind right now that you have told us about less than half filled, you have told us about the more than half filled, what about the equal or the exactly half filled case? So you will be observing here, let's say there is an element and I'm writing its electronic configuration like we used to write in chemistry. So same way I'm writing it here, and the last term I'm going to have there is P3, okay, in that configuration. So now I want to write its ground state spectroscopic term. What I have to do in that case? I can fill or have the total 6 electrons in this case. So ml values corresponding to the p orbital. For p, L is equal to 1 and ml will be plus 1, 0 and minus 1. So I need to fill the 3 electrons there. Now in that case, summation ml will be equal to what? That's going to be 0, okay? And that's going to be what? S. Clear? In this case, summation ml means what? I'm just adding plus 1, 0, minus 1, done. This is how we are going to consider it. Next thing, the ms is equal to what? Half, half and half. Done. If there will be another electron having the opposite spin will be there, so that will have the like ms value minus half. So summation ms is what? 3 by 2 in this case. And you will be treating it as S, you will be treating it as L. So L is equal to 0 means, L values means like 0, 1, 2, 3. So your like values of capital L are S, P, D, F. Done. This is how you will be having all these values. Now the next thing, S is there, which is 3 by 2. So in this case, 2S plus 1 will be what? 2 into 3 by 2 plus 1, which is going to be 4. This is what we are going to get, okay? So what is the notation I'm going to have? Now J is equal to what? Finally, I just want one more term. What is that? That is J. J is equal to L minus S to L plus S, which is 0 minus, that's going to be 3 by 2 to 0 plus 3 by 2, which is going to be equal to 3 by 2. So 2S plus 1, which is going to be 4S 3 by 2, okay? This is the only term you have got. There are not so many different terms or so many terms you are getting here, which means this is going to be the ground state spectroscopic term, okay? That's the process you have to follow, and this is a trick which is going to help you to get the ground state spectroscopic term notation. In the same case, okay, if I'm going to consider the next thing here, for example, instead of taking exactly half filled case, I'm going to take D2, okay, D2, which is not exactly half filled. This is going to have more, you can say less or more case, okay, less than half filled or more than half filled. So when it's D2, what is the L value? I want to find the ground state spectroscopic term here. So L value is what? That's going to be just, you can say 2, okay, SPDF 0, 1, 2. Then ML values will be what? Plus 2, plus 1, 0, minus 1, minus 2. Then spin is what? Like, let's just consider the structure completely and let's talk about it. Maximum number of electrons we can have in d orbital are 10. So 1, 2, 3, 4, like total 5 partitions we had. How many we need to fill? Only 2 electrons. So what is the ML value you will have? Plus 2, plus 1, 0, minus 1, minus 2. What about the MS values? Half and half. So this is going to be summation MS is equal to half plus half 1. Summation ML is equal to 2 plus 1, 3. So now you will be finding J. J is equal to L minus S to L plus S, 2, 3, 4. Now you are going to get 2S plus 1. That's going to be 2 into 1 plus 1, 3. L is equal to 3 means SPDFF. And then J values are 3, that is 3F2, 3F3 and 3F4. These are the values you got, okay? Now, in this case, what will happen? It was less than half filled case. You can see 2S plus 1 values are same. L values are same, but the J values are different. So what you will have to do? It is less than half filled case, lowest J value will have the lowest energy, which is this. That's it. Instead of finding all the spectroscopic terms or following all those steps to find all the spectroscopic terms, this way you are reaching to the final answer. Now, this was one way of finding it, okay? And this trick is only applicable for finding the ground state spectroscopic term. If in case there is anybody like having any doubt regarding the steps you have to take or the whole process we have followed or anything, in that case, you can let me know about it. And if everything is clear, that's great. Okay. Next thing. if I'm going to talk about the next thing here, that's going to be related to finding the total number of spectroscopic terms and all the spectroscopic terms. But this trick which I'll be telling you is applicable for the two equivalent electrons case, like D2, P2, F2, like that. Okay, but the process will remain same. Only for two equivalent electrons case you can apply this trick which I'll be telling you now. What is that and how it will be helping you to find the all spectroscopic terms quickly, easily and in less time without directly applying the Bright's scheme? We will be getting all the spectroscopic terms with this trick. Let's work on it. For example, P2. What is the L value? That's going to be 1. What about the number of electrons which are there? 1 into 2, which is 2. Okay, because 2 electrons were there, so I have taken those number of electrons here. Next thing, you have to write the 0 to 2, all the values here, which is 0, 1, 2. Okay. Next thing, these are what? These are your L values you got. Now you have to take the spin. Even L, even spin means 0 and 0. Odd L, odd spin means 1. So what I have considered till now, 0, 1, 2. S is equal to 0, 1, 0. J is equal to L minus S to L plus S. Now this is going to be all the values you got. Next thing, 2s plus 1 Lj, which is going to be S here for 0, 1, P, 2, D. 2s plus 1 is what? That's going to be 1. 2s plus 1 is what? That's going to be 3. 2s plus 1 is what? That's going to be 1. It's going to be 1 is 0, 1 is 0, 1, 2, 1D, 2. This is what we are going to have. Clear? Now you have got all the spectroscopic terms. These three terms can be taken as like one by one. You can write them 3p0, 3p1 and 3p2. That's all right. So this is how you will be able to consider all the spectroscopic terms. Okay. And same way, I'll be showing you one more example for this case, which is going to be for D2. So how you will find the all spectroscopic terms, and this is only applicable for the two equivalent electrons. I'll be taking L value. Excuse me. That's going to be 2. Number of electrons 2. So 2 into 2, that's 4. 0 to 4, all the values I need to write. 0 to that value. 0, 1, 2, 3, 4. These are the L values. Spin, even L, even spin. So since 2 electrons you are taking, okay. So if one is half, another one can be half as well. If one is half, another one can be minus half as well. So this is how you will be taking it, which means if you are having the total values, it can be either 0 or it can be 1. So what I'm going to take for 0, 0, 2, 0, 4, 0, odd L, 1, 1. It's basically why we take it this way. It's the Pauli's exclusion principle, that if you are having the electrons present in the same orbit, then in that case, you can't have their spin same. That should be opposite. So mainly these electrons with the orbits which you are taking, when you take the same spin electrons present there, you take their spins opposite. Okay, sorry, when you take 2 electrons there, you take their spins opposite. So one is going to have the spin half, another one will be having minus half. So it makes the total spin 0. Same way here and here. When you keep the same spin particles, you are having same spin particles. So you can't keep them in one state, you will be keeping them in different states. So as per the Bright's scheme, we make this kind of a structure. We write the ML1 here, we write the ML2 here. And if I am showing for P2 how the Bright's scheme will be working instead of D2. So we write the ML1, which is plus 1, 0 and minus 1, plus 1, 0 and minus 1. We add those values, we write, this is the detailed method. But that was the trick I have shown you even in the previous example. And this is just for the 2 equivalent electrons we will be using. If more than 2 equivalent electrons will be there, then mostly they ask us to find the ground state spectroscopic term instead of finding the total overall, all the spectroscopic terms there. So if you will see NET GATE just here for previous year question papers, in that case you will be finding that similar type of questions have been asked in the previous years. Okay. Now, next thing, it's going to be plus 1, 0 and minus 1. It's going to be 0, minus 1 and minus 2. So you can see 2 and 0. As in the previous example, I have shown you for 2 and for 0, I have taken the spin 0. Reason behind it. So that's what I'm going to explain here. For 2 and 0, if you will see, you are going to have the same states, means +1 here, same way +1 here, 0 here, 0 here, -1 here, -1 here. Same states, while the ML1 and ML2 values are same, so you will be saying like, oh, states are same, so I can't have the same spin. I have to take the different spins, which are opposite spins, +½ and -½. That's why for 2 and 0, I was taking 0, 0. Okay, and in the previous case for P2 case as well. So that's how it was working. If in case there is anybody having any doubt in this part, you can surely mention it. I'll be talking about that too. But if it is getting clear, that's great. So this is what's going to happen. 2 tricks you have learned till now. Okay, one is to find the ground state of spectroscopic term, and other one to find all the spectroscopic terms. So this was the trick. Now again, you can make the table, write L values, write S values, write J values, write all the spectroscopic terms as done in this case. After knowing about these tricks, now I think it's going to be quite simple and easy for everyone to find the total number of spectroscopic terms as well as to find the ground state spectroscopic term for any such case. If there is anyone having any doubt in this case, you can just let me know about it. Same way guys, based on it, if you will have any questions, you will be able to do them. Now based on this trick, you can check out the previous year questions and you can try them, you can solve them. And I think, excuse me, that's going to be quite simple and easy for you to consider and to solve those questions. If there is any doubt, any question, any query anybody is going to have, just mention it. I'll be talking about that. And if everything is clear, that's great. So let's keep it this much. Thank you so much everyone for joining this session. And yeah, once again, I'm just gonna quickly show you all those slides which I have shown you in the starting. And here is the iconic subscription related slide, then plus, then light subscription, and the difference between the plus and the iconic subscription. Along with all these important slides, I'll be showing you the another one, which is the latest update we are having regarding the Unacademy subscription. Okay, now let me know if in case there is any doubt anybody is going to have at any point. More details have been shown on this slide, so I hope it's gonna make many things clear to you. And guys, since in upcoming days so many new courses by the top educators will also be starting on Unacademy, so in that case, if you want to take the Unacademy subscription or you want to join more well structured and well planned courses sessions, then you can take the subscription and start your preparation under the guidance of top educators. So we will be keeping it this much right now in this session guys. And since the new month is starting, so with the starting of the new month, many new courses will also be starting. For the joining those courses, you can take the subscription today and start your preparation under the guidance of top educators. Thank you so much everyone for joining this.